Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we're about to solve are the ones that you will find on page number 309. Please turn to it. Page number 309, and today is our lesson number 26. Very first problem on the page, problem number 23. In problem number 23, we are given two functions. F of x, which we are told is x squared plus x plus 5, and then we are given g of x, which we are told simply equals square root of x. And the question is simply, what's the value of this quantity? F of g of 4 over f of 1. This is how we read it. This is read as g of 4 over f of 1. G of 4 simply means the value of the function when x happens to be 4. So let's find out value. What is the value of this function when x happens to be 4? Well, we just substitute 4 in here, and square root of 4 is 2. So it turns out that g of 4 equals 2. So that's the top part. Similarly, f of 1, we simply replace wherever we see x here, we replace it with 1 and figure out the value of the function. That's all. So f of 1 will equal to 1 squared plus 1 plus 5. 1 squared plus 1 is 2, 2 plus 5 is 7. That's all. That is our answer. 270 is our answer, and that happens to be answer choice A. Answer choice A. Next one. Problem number 24. Problem number 24. In the next problem, we are told that we have 125 juniors. We have 125 juniors and we have 100 seniors. And the question simply is, how many different ways are there to select a pair of junior and a senior? How many different ways we can select a pair of junior and a senior? How many different ways, it should say not we can select, but how many different ways can we select? How many different ways can we select a pair of junior and a senior? Let's find out, shall we? How many different ways can we pick a junior? Well, that's pretty straightforward. How many different ways can we pick a junior? There are 125 juniors. There are 125 choices. There are 125 ways we can pick a junior. How many different ways we can pick a senior? Very simple. How many different ways we can pick a senior? There are 100 different seniors. We can pick any one of those 100 people. And therefore, altogether, the number of ways that we can pick a pair is 125 times 100, which is simply 125 with a 20 at the end. Comes out to be 12,500. And that's answer choice K, the very last one. Answer choice K. Number 25. Number 25. In number 25, we are told that the slope is 5%. We are told that the slope is 5%. Now, what is the slope? Slope, as we all know, is simply the ratio of the change in y to the change in x. The slope tells us how much y rises, how high do we go for every 1 unit change in x. And that we are told is 5%. We are told that that slope is 5%, which means that if the change in y happens to be 5 feet, then change in x has to be 100 feet. That's what that means. 5% slope means for every 5 feet change in y, the change in x has to be 100. If you want to look at it in terms of, a triangle, it looked like this, except I have to redraw it. It did not, it has to be 90 degrees. It has to come straight. So from here to here, that's our change in x. The change in x is 100 feet. And if we go 100 feet this way, then as a result, we'll climb a height of 5 feet. And that's how the slope of the road is, or slope of whatever it is. In this case, I don't know. So I don't think it's a road, but whatever happens to be, that's the slope. I think we're building a ramp for a wheelchair for a handicapped person, but we do not want to go all the way up to 5 feet. From the bottom of the ground to the top of the entryway of the door, that's only 2 feet. It's only 2 feet. The question is, how long does the ramp needs to be? If we just want to go 2 feet, we don't want to go all the way up to 5 feet, we just want to go 2 feet. The question is, how long does the ramp need to be? This distance is we are looking for. Let's find out, shall we? And of course, the slope that we see here, this slope, is going to be same as this slope. These two angles are equal. This angle has to equal that angle because these two lines are parallel. This line is parallel to this line. And therefore, what we're trying to figure out is, if you want to go 2 feet, how long does the ramp need to be? We just want to go 2 feet. We don't want to go 5 feet. We just want to raise by 2 feet. Let's find out. Enough of the talk. It's very simple. Cross multiply 5 times x. 5 times x. If you cross multiply, 5 times x equals 2 times 100. 2 times 100. And therefore x will equal 2 times 100. Or better yet, we can just do it here. Divide both sides by 5. 5 drops out and x equals 2 times 100 over 5. How many 5s in a 100? Well, our 10 has 2 5s and then there is a 0 here. So there are 25s in a 100. Of course there are 25s in a 100. We know that obviously. Everybody knows that there are 20 nickels in a dollar. A dollar is made up of 20 nickels. So it's 20 times 2, which is 40 feet. In other words, our ramp only needs to be 40 feet long, not 100 feet long. If you make a 100 feet long ramp with a slant of 5%, that will raise the height to 5 feet. We don't want to go all the way up to 5 feet. That's it. The ramp needs to be 100 feet. The answer is, or whatever the answer is C. Let's move on then. The next one, number 26. We have a temperature. Next one. I always make sure that I give you unobstructed view of the blackboard for at least 3 seconds in case you want to pause the screen there. The temperature is T degrees, and we are told that the temperature on a given day satisfies the following inequality. And the inequality that they give us is this. We are told that the absolute value of t minus 24 is less than or equal to 30. Now this is the part we need to understand. What does it mean? How do we go about handling this thing? But don't make it very complicated. Look at a simple scenario first. For example, if somebody tells us that the absolute value of x is less than or equal to 5, okay, let's look at a simpler scenario first here. What does it tell us? Well, here's our number line. Here is a 0. Here is positive 5, and here is negative 5. Obviously, things are going on in that. Let me erase the negative 5 because negative 5 is too close to 0. It's not as far. It doesn't have to be accurate, but you have to be reasonable. Ask yourself, what happens if x happens to be negative 7? Absolute value of negative 7 is positive 7. And positive 7 is not less than or equal to 5. Positive 7 is not less than or equal to 5. In other words, x cannot be here. X cannot be here. I shouldn't have written it there because now it's too crowded. Can x fall here? Can x be negative 7? The answer is not. The answer x cannot be negative 7 because absolute value of negative 7 is not less than or equal to 5. Absolute value of negative 7 is positive 7 and positive 7 is not less than 5. Can x be negative 4? Can x be negative 4? The answer is yes, because absolute value of negative 4 is going to be positive 4, and that is in fact less than or equal to 5. Can x be positive 4? Of course x can be positive 4, because absolute value of positive 4 is positive 4, which is less than 5. Can x be negative 10? Can x be positive 10? Can x be positive 10? The answer is no, because the absolute value of positive 10 is not less than or equal to 5. So what do we conclude? We conclude that when they tell us that when we are told that the absolute value of x is less than or equal to 5, what we conclude is that tells us that the x, whatever the hell it is, this x has to fall somewhere between negative 5 and a positive 5. Somewhere between a negative 5 and a positive 5. It has to fall between this region. Let me erase everything here so that we can see it clearly. It has to fall in this region. Between negative 5 and positive 5. Whatever appears in the absolute sign, listen carefully, whatever that appears in the absolute sign has to fall between negative 5 and a positive 5. That 5 tells us we are 5 units away from the 0 on the left hand side, and we are 5 units away from the 0 on the right hand side. You understand? It cannot be negative 7, it cannot be positive 10. It has to fall. Here is your 0, here is your positive 5, here is our negative 5. It has to fall in this region. Whatever that happens to be, whatever that appears in the absolute sign. Now it just so happens that here, pretend that x equals t minus 24. Well, if x equals t minus 24, then the same thing would apply here. That tells us that t minus 24, in this case is not 5, it's just 30. Has to be less than or equal to positive 30 or greater than or equal to negative 30. That's what it tells us. Do you understand? I want to erase the thing, I don't want to confuse you there. So look at the simpler scenario first and compare it with this one. That's it, we are done. All we have to do now is solve for t. Let's do it, shall we? And how do we solve for t? Well, we solve for t by getting the t by itself. Somehow we have to separate the t, get it by itself. Separate it from everything else. The only thing that is attached to t is this negative 24. We have to get rid of this negative 24. How do we get rid of the negative 24? Well, it's very simple. By adding 24. Add 24 to this part, add 24 to that part, add 24 to that part. Voila. Since we are adding the same number to all three parts of the inequality still holds. Negative 24 we cancel out with positive 24, that was the whole point. We are left with only the t. T, now we know, has to be less than or equal to this quantity right here, 30 plus 24, which is 54, or it has to be greater than or equal to negative 30 and a positive 24. Negative 30 and a positive 24 is negative 6. There you go, voila. So what this tells us is that on a given day, whichever the day that they're talking about, one day that they pick there, what they're telling us here, what this equality tells us is that on that particular day, the lowest temperature that you had in the middle of the night was negative 6 degrees, but during the day it warmed up all the way up to 54 degrees. Oh my God, that's quite a sweep. That's quite a sweep. That's a 60 degree march, 60 degrees range there. It went all the way from negative 6 during the middle of the night, all the way up to, in the afternoon, it warmed up all the way up to 54 degrees. And what's the answer here? What is the question asking here? Let me read it. It says, oh, the question is actually very different. It says, which of the following temperature is not in the range? Oh, this is interesting. Not in the range. Let's start with K. Let's start with K. I did not write down all the answers, but so I have to copy it from here. K is 54. K is 54. J is 0. H is negative 5. G is negative 6. And F is negative 10. Well, obviously you can tell why I'm writing them in this order, because I don't want to give the game away. We're going to build a little suspense here. Is 54 in this range? The answer is yes, because we are allowed to, T is allowed to be less than or equal to. T is allowed to be less than or equal to. Temperature, as I told you before, temperature rose all the way up to 54 degrees. So that is in the range. So is 0. 0 falls in this range. 0 falls between negative 6 and 54. Negative 5 falls between negative 6 and 54. And so does negative 6. Negative 6 and k, those were the two extremes. Those were the endpoints. Negative 10 does not fall in this range. Negative 10 lies outside the range. It did not get that cold. That's out of the range. Now instead of negative 10, had it been 60 or 60 or 70 or 100, then we would have said that it does not get that hot on that day. It only got as hot as 54 degrees. It only got as cold as negative 6 degrees. The temperature never fell all the way down to negative 10 below as we call it, or negative 10 degrees. Let's go to the next one, very last one, number 27. Number 27, just give me a break. I need my break. Number 27. It says when 5 times n is subtracted from 15, the result is negative. The result is negative. Okay, very good. The question is, what's the possible values of n? Possible values of n. Not possibles. Possible values of n, obviously. So let's find out, shall we? So here we have 5n minus 15. And that quantity we are told is negative. What does it mean for a quantity to be negative? That means whatever this quantity is less than 0. Now, did you notice a problem here? Do you see a problem here? Do you see something funny going on here? What did I just do? What I did here was, what this says, okay, listen carefully, what this says is that 15 is subtracted from 5n. What I've done here is 15 is subtracted from 5n. Is that what this says? It says 5 times n is subtracted from 15, not the other way around. What I've done here is that I have subtracted 15 from 5n. We are supposed to subtract 5 times n. We are supposed to subtract 5n. Subtract that quantity, subtract this quantity, 5 times n, subtract this quantity from 15. This is wrong. 15 is being subtracted from 5n. This is wrong. This is not correct. That's not what we need. What we need is this. What we are being told is this. 5n, this quantity here, is being subtracted from 15. And as a result, what we get is a negative quantity. Negative quantity simply means that this result is less than 0. That's all. We just have to solve for n. Very simple. How do we solve for n? Well, let's add 5n to both sides. This 5n is going to drop out. And that tells us that 15 is less than 5n. If 15 is less than 5n, which is same as saying that 5n is greater than 15. It's always a good idea to put the unknown on the right hand side. 5n is greater than 15, which is same as saying 15. If 15 is less than 5n, then 5n has to be greater than 15, obviously. Divide both sides by 5 and we're done. Divide both sides by 5 and we're done. And the answer is, n, whatever it is, has to be more than 3. N has to be more than 3. And among the answer choices that are given to us, A, B, C, D, and E, E says 0 only. That's wrong, obviously. Any value more than 3 will do. Any value that is more than 3 will satisfy this statement. It says 0 only, that's not good. The next one says 3 only. That's nonsense. It's not 3 only. As a matter of fact, 3 is not even allowed. It has to be more than 3. Any value that is more than 3. It doesn't even allow it to be equal to 3. It has to be more than 3. That's wrong. 10 only. That's another nonsensical answer. D says, oh, there you go. D says n is more than 3. There you go. That's our jackpot. And E says just the opposite. E says less than 3. That's not it. That's not it. The answer is n has to be, n whatever it is, has to be all values of n. It doesn't matter what n might be. Any value of n would do as long as it is more than 3. It could be 3.1, or it could be 3 million, or it could be 30 billion. We really don't care. it will work here. I'll see you tomorrow, okay? Bye now.